Hello, hello everyone. Hi. Well, before starting the journey, let me just all welcome you to the big data world. So, before directly rushing into the topic, let me just introduce myself. Where myself, Vignesh, the Cloudera certified Hadoop developer, big data certified analyst, and I am the chamber member of IBM's Big Data University. And currently I have been working with HP, where previously I worked with Cisco client and previously worked with Flipkart, with Wells Fargo, and previously I worked with Merck Pharma. So these are all the clients so far I dealt with, where I have totally of 13.9 years, around 14 years of experience, out of which 2.8 is exclusively on top of Hadoop. And the great I could able to share that a great privilege is that I have been working with direct Cloudera University, where I have been working as a direct trainer for the Cloudera University. Here you can see that it's a Cloudera University's important information, where I have the direct ties with Cloudera University. So this is a simple profile of mine. So let me just start this journey with a simple example. Well, let us say that we opened a bank account somewhere in 2000. 14 years later, that is in the year of 2014, we approached the bank and we asked them for the past 3 months bank statements, where 3 months bank statements we can expect in the span of half an hour or at most of 1 hour of time. Very less span, because hardly 3 months data. The very next day we approached the same bank and we asked them for the past 10 years bank statements, where 10 years bank statements we cannot expect in the span of half an hour or 1 hour. A well-known fact, because we know that all our data will be moved to the backend, stored in huge magnitudes, in Teradata or NetAsia, and moving further with ETL, data warehouse, generating reports, and SAP for data management. So everything comes into the picture. And in this due course of storing your data and processing the data, we have almost a dump of drawbacks. So let me share you what are all the existing data storage and data processing methodologies and their drawbacks. And then let me share you how Hadoop can overcome all those drawbacks in a successful way, and how Hadoop can handle the so-called big data. So let's get started. Well, let me initially talk about existing storage and processing methodologies and the constraints, the problems with the existing methodologies, why we need to look for an alternative. Well, I classified data as people's data and machines data, because these two are the major sources where we usually get huge magnitudes of data sets from. Where when I talk about people's data, we usually upload images, videos, likes, comments, shares, tags, applications, tweets, charts, posts, whatnot, everything in our social networking websites, and from e-commerce, online reservations, online banking. So literally we will be generating huge magnitudes of data. And machines data like RFID readers, GPS traces, satellite communications, so these all fall under the category of machines data. So almost the data literally will be generated at the range of hundreds of terabytes or even at the range of petabytes per day. And of course, if you consider the history, handling the large data sets is a problem with the organizations like Google, Yahoo, Amazon, Facebook, because these are all the organizations who have been dealing with large data sets. But literally, this is the problem. Today, handling the large data sets is not only the problem of these organizations. Almost 80% of the industry is suffering from the problem of handling the large data sets. At last, I passed a bold statement here stating that existing methodologies are completely becoming inadequate in handling the large data sets. Let me share you why I passed the statement and what are all the existing methodologies which were inadequate in handling the large data sets. So, let me start with data storage initially. And when I talk about data storage, the first and foremost word which will strike our mind is nothing but RDBMS, which has been ruling the industry over 2 decades. Well, though RDBMS is having its own trademark, it has several drawbacks. Let me share you like this. Point 1. RDBMS can handle only the structured data. It cannot support the unstructured data. When I talk about the unstructured data, the data on which you cannot define any schema is nothing but the unstructured data. Like images, video files, audio files, XML files, HTML files, log files. So these all fall under the category of unstructured data, where RDBMS will literally fail in handling these unstructured data sets. That's a major problem. And we know that we usually opt SAN disk space for the storage level. We'll be having LUN allocations. We'll be having some storage allocated for our RDBMS so that we'll be utilizing that storage. And at the SAN level, we need to talk about the hard disk, what sort of hardware that they have been utilizing on. SAN perspective, they usually use FC disks, fiber channel disks, and the latest enhancement like SSDs, solid state drives, which are very expensive. So simply, storage part, hardware is very expensive because of FC disks and SSDs. That's a simple problem, because it is very expensive because of high-end hardware, and number 2, there is no support for unstructured data. So simply, when I talk about the data storage level, the most sounding constraints are there is no support for unstructured data, and it is very expensive because of high-end hardware. These 2 are the most sounding constraints at the range of storage level of RDBMS. And the largest disk space allocated will be at the range of 24 TB drives. So some have, since we don't have any alternative, we have been storing the data at the range of SAN perspective. And once the data was stored, we need to process it, where the words like data warehouse, ETL, some things comes on the picture, and SAP for data management. And none of these technologies will work with cheap hardware. They require literally blade servers and Spark processors to work on with, which are very expensive. And they're not open source. You need to purchase the license, which will make the things much more expensive. And simply I can share you that data processing became very expensive because of high-end machines and the licensing problems. So that is a major constraint at the range of data processing. And above all, if you want to process the data, initially you need to transfer the data from the storage center to the processing units, for which you need to seek the help of network. Almost using FC cables, fiber channel cables, we can attain a transfer speed of almost 16 Gbps, 16 Gbps. Excellent speed. 16 Gbps is an excellent speed, we know that. though the data could be transferred at the range of 16 Gbps, the disk cannot retrieve the data at that much faster, because if you want to transfer the data, initially you need to read the data from the disk and then transfer it across the network. Disk speed is very less. It was hardly at the range of 500 Mbps, this much. But your network is at the range of 16 Gbps, this much. And so simply giving you a bottleneck problem. This is also a constraint. And we know that we usually use Unix flavor of operating system, like we usually go for Solaris or AAX or HP Unix, any flavor of Unix operating system, usually at the range of storage level. And we know that the block size at the range of Unix is of 8 KB block size. Let us say like this. Let's say that you stored 64 MB of data. After all, for storing 64 MB of data, Unix file system consume 8,000 blocks. And if you want to retrieve your data back, your disk head need to be moved from one block to another block, and so on, 8,000 blocks. The time taken by your disk head to retrieve your data from one block to another block is what we call as disk seek time. Because the block size is less, seek time is huge. That's also a constraint. So on the whole, let us conclude what are all the existing storage and processing methodology constraints. They are just like this. Point 1. There is no support for unstructured data. It is very expensive because of high-end hardware. And 3, the bottleneck problems. And 4, disk seek time. So literally, we need an alternative, a new technology which will support the unstructured data, which will eradicate the disk seek time, which will vanish the network constraints, and that new technology should not be expensive. And that new technology which had all these features is nothing but Hadoop. So Hadoop will give us a support for unstructured data. It will eradicate disk seek time and bottleneck problems. And it is very, very cheaper in cost. So these all features made the industry to deviate themselves towards Hadoop. And perhaps you might shoot me with a question, why I am poking much about the data? And here it is. I'm sure majority of us might have heard about this organization several times. IDC, International Data Corporation. According to the statistics of IDC, the world's data in the year of 2006 is 0.18 zettabyte. By the end of 2011, that is in 5 years span, it increased 10 times and it came to 1.8 zettabyte. Where by the end of 2020, they are expecting this to reach 40 zettabyte. And observe, 40 zettabyte is not a simple figure. It's huge. Simply, let us make like this. We know 1 zettabyte equals to 1024 cube terabyte. Let us make it approximate. So 1 zettabyte equals to 1000 cube, which is around 10 power 9. Right. So 40 zettabyte equals to 4 into 10 power 10 terabyte of data, or else simply 40 into 10 power 9 terabyte of data. This is the magnitude of data which we can expect by end of 2020. How many 24 TB drives do we need now to store this magnitude of data? Not only simply storing it, you need to provide the redundancy also. How many $1 million do we need in order to process this magnitude of data? And how many days do we need in order to transfer this with the existing bottleneck problems? The thought itself conveys us that we are choosing a wrong path. We need an alternative. That is nothing but Hadoop. Above all, 80% of this data gonna be unstructured. And we the people are generating this unstructured data from the social networking sites, uploading images, videos, likes, comments, shades, tags, applications, tweets, chats, posts, several things. And we classified mails as semi-structured data because if you consider an email, you'll have to CC, a BCC and from, where you can define a schema on the mail ID and you can store it, not a big deal. But can you define any schema on the text body of the mail? And majority of the mails may have attachment and many may not have any attachment. And that attachment might be again unstructured. The attachment might be an image file, it might be a video file, it might be a PDF file, but the mail IDs are structured. So we classified that as semi-structured data. And the machine's unstructured data, like RFID readers, GPS traces, and the log files, where when I address about the log files, usually access log files will be disabled at the server level. It's a well-known fact. But if you have the technology to deal with these log files, you can generate money out of this dump. And this is the place where about 90% of the e-commerce is currently focusing on. We processed the log files of Flipkart, where we generated 38.6% of their revenue. That is again through Hadoop. And before sharing you exactly what exactly is Hadoop, let me talk about this term, big data. Well, big data is not a technical term. It's not at all a technical term. Any data having several characteristics could be addressed as big data, where its volume, velocity, and variety. Where volume talks about the magnitude of your data, whether your data is at the range of terabytes, petabytes, exabytes, or even at the range of zettabyte. Magnitude. Velocity indicates the rate at which the data is getting generated and the rate at which you need to process that generated data. That is nothing but velocity. Variety talks about the type of your data, whether it is structured, semi-structured, or unstructured. If your data is of huge magnitudes, which is of semi-structured or unstructured, and getting generated at high speed, yes, you can address your data as big data. It is Hadoop which can handle this big data in an excellent way. So now let's discuss how Hadoop can handle this big data in an excellent way. So before delving into this, let me share you. Whenever I address as Hadoop, Hadoop is always at a cluster level, where a cluster is nothing but combination of nodes connected across a network. And a node is nothing but a simple computer. So let me share you simply. A cluster is nothing but combination of computers connected across a network. And when I install Hadoop on each and every computer, it will simply become a Hadoop cluster, not a big deal. So let's say that we purchased 100 machines, connected them in a network, and we installed Hadoop on all these 100 machines. So ours is a 100 node Hadoop cluster. No sooner than when I install Hadoop, Hadoop will accumulate two major components across the cluster size, across the cluster. That is nothing but HDFS and MapReduce, where HDFS is completely for storage and MapReduce is for processing. HDFS, Hadoop Distributed File System. The name itself conveys us. Hadoop Distributed File System. Well, let's say that you uploaded 1 TB of data. So your 1 terabyte of data will be made into 64 MB chunks, because the major difference between normal distributed file system and Hadoop distributed file system is that the block size itself is of 64 MB, a huge block size. So when you upload a file of 1 terabyte, your 1 terabyte file will be broken into 64 MB blocks, chunks, and those 64 MB chunks will be scattered across your 100 machines. So literally Your 1 terabyte was distributed across your 100 machines with a block size of 64 MB. Observe, 64 MB block size is not a simple block size. Let us talk like this. Consider you would like to store 128 MB of data in the Unix file system. After all, for storing 128 MB of data, it will consume around 16,000 blocks because the block size is of 8 KB. The same 128 MB of data in Hadoop will consume only 2 blocks because the block size is of 64 MB. Imagine about the disk seek time in case 1 and the same disk seek time in case 2. Since the block size is huge, disk seek time got drastically reduced. One of the drawback, disk seek time is no more on top of Hadoop because of the large block size. And if you observe, you are storing the data directly in the range of file system. So that was the main reason why you can expect the support for unstructured data. Even that was the main reason why we could able to store images or movies, songs on our laptops or on our PC, because we are storing them directly in the file system, and Hadoop is also the same. So there is a support for unstructured data, and once after your data was uploaded, if you want to process that uploaded data, you'll simply design a MapReduce job, where this MapReduce job can be designed either in Java, Ruby, Python, Perl, or even in C++. But majority, as we have Java programmers, people usually go for Java MapReduce. You'll design the MapReduce program in Java, simply make a jar file out of it and upload that. So it's your jar file which will travel towards your 100 computers and will process the data there itself. So if you observe, you are storing the data across your 100 node cluster and you are processing the data on the same cluster. Storing the data and processing the data on the same cluster. So there is obviously no network issues involved. And above all, whatever the machines that you are using in this cluster are of cheap hardware. Hadoop does not require anything like blade servers or Spark processors to work on with. It will work with a very basic hardware. Even that was the main reason why we could able to have Hadoop on our laptop. There is Hadoop installed on this laptop, on my laptop. On 5th day of our journey, we will be installing Hadoop on your PC or on your laptop, because Hadoop works with cheap hardware. Your laptop is a cheap hardware. My laptop is a commodity hardware. So Hadoop works with it. On the whole, if you observe, there is a support for unstructured data because you are storing it at the range of file system. The disk seek time got vanished because of the block size 64 MB. The network issues got drastically reduced because you are storing the data and processing the data on the same cluster. And above all, everything is available at the range of very cheap cost because Hadoop works with cheap hardware and no licensing issues. It's an open source through Apache. What else do we need? All your 4 drawbacks are no more with Hadoop. And this is what I mean to say. Data storage and data processing at one hub, and that hub is nothing but your cluster. This is the fastest processing. This is not what Vignesh is boasting about Hadoop. This is IBM's declaration. We processed 1 terabyte of unstructured data using RDBMS, which consumed 28 hours to process it. The same 1 terabyte of unstructured data using Teradata consumed 6.5 hours to process it. The same 1 terabyte of unstructured data on Hadoop, a 180 node cluster, consumed 3 minutes 27 seconds to process it. The same 1 terabyte of unstructured data using same Hadoop 180 node cluster, but using the latest architecture called as YAN architecture, could make it in 1 minute 19 seconds. That at a cheap cost. And this is what I mean technically. So if you want to handle your big data, just upload your data to the cluster, where here mine is a 3 node cluster, only 3 machines. So your data will be broken into 64 MB chunks, and your chunks were stored just like this in a distributed fashion. And if you want to process this chunks, you'll design a computation, nothing but you'll make a MapReduce job. You'll make a jar file out of it, and it's your jar file which will travel towards your data. Observe, your data is stagnant. You're not moving your data. It's your computation, nothing but your jar file, which is moving towards your data. So it will process the data across the cluster in a parallel way, just like this. On the whole, it's a parallel processing, but if I delve deeper, on each and every machine, it will create several instances of JVM, and it will process still more parallelly. So MapReduce is not a simple parallel processing, it's a massive parallel processing. That's what MapReduce is. A massive parallel processing approach of handling the data sets. That with a cheap cost. And this is the core concept of Hadoop, where it is easier to move the computation rather than moving the data. That's what we have been doing here. Your computation is getting moved towards your data, and your data is being stagnant. And it's a massive parallel processing for the ease of handling the data sets. And that was the main reason why we went on with a distributed file system. And it is easier to deal with the small data chunks rather than dealing with big data sets. That was the main reason why we went on with a distributed file system. And above all, you can achieve the things with commodity hardware, which costs nothing. And this is a quite common question that people usually post me on. But they usually share me just for the sake of distributed storage and parallel processing. Why should we require new infra called as Hadoop? Can't we make the things with the existing methodologies? Of course they can, but the problem involved is just like this. Let's say that I purchased 10 disks and I installed Hadoop on each and every disk. So Hadoop was installed across the 10 disks. Sorry, I purchased 10 disks and I installed RDBMS across all the 10 disks. And I would like to store some 100 GB of data. So my 100 GB of data was stored across these 10 disks in a distributed fashion, 10 GB per disk. And if I want to process it, I'll connect each and every disk to a resource and I'll process all the 10 disks in a parallel way. That's what they usually mean to say. It's a good thought actually. Hadoop also do the same, storing the data across the machines and processing it in a parallel way. They can go ahead with that, but what about the disk seek time? What about the data type? Because RDBMS will support only the structured format. And what about the replication, providing the redundancy, which is going to be expensive? Because of that, we require alternative, nothing but Hadoop. And I'm sure majority of you might have heard about these weights. For the people who are from the programming background, can rock at this area where the MapReduce part is exclusively designed for the programmers. If you want to deal with the MapReduce area, definitely you need to have a knowledge of programming. If not, we cannot. But for the people who are not even from the programming background but still want to work on with Hadoop, yes, you have an alternative called as Hive, which has its own query language called as Hive query language. So whatever you need to do is just pass a query. So pass a query, and this query will internally generate MapReduce job and process the data sets. So it's an alternative to design the MapReduce job. Let's say that we are not even from the SQL background. We have another ecosystem component called as Pig, which has its own scripting like language called as Pig Latin. And whatever the script you design, that will be generating the MapReduce job. So Pig and Hive, they are alternatives to design the MapReduce jobs. And Scoop is another ecosystem component. I can address that as a utility tool to ingest the data from different RDBMS to HDFS. We're using Scoop. You can ingest the data from Oracle, MySQL, SQL Server, DB2, even from Teradata, NetAsia. So It's a alternative to to ingest the data from different RDBMS to HDFS. And Avro is to deal with serialized files, encrypted files. And HBase is a NoSQL database. The name itself conveys us NoSQL, not only SQL. You will not have anything like normalization here. No primary keys, no foreign keys. It's not a row-oriented architecture. It's a column-oriented architecture, where your data will be stored in key value pairs, and that too it will store your unstructured data. Of course, you have almost 150 NoSQL databases, where some of them are like HBase, Cassandra, MongoDB, Neo4j, Couchbase DB, Accumulo, Dynamo, Bigtable. So these all fall under the category of NoSQL databases, and HBase is one among them. And Zookeeper is a coordination service which will have the internal coordination among these ecosystem components. Each and every ecosystem component, whatever I addressed here, Hive, Big, Scoop, everything is an open source. Hadoop itself is an open source, but let us be practical. We know that no organization will dare to work with open source, that too with new technology, because let's say that we purchased 100 machines and we downloaded Hadoop from Apache site. We installed across the 100 machines. We configured it. Meanwhile, we had an issue. We cannot expect any support from Apache. We downloaded, we'd like to have Hive, so we need to download it from Apache, install it and configure it. If you have an issue, no support. And above all, since it's an open source, you cannot even expect a well-versed user interface on top of it. It's majority based on command line. So that's also a problem. Owing to these constraints, there were several organizations who came forth where they'll be giving you an excellent technical support, a very good user interface, and they will offer all these ecosystem components as a package. Where some of those organizations are like this: Cloudera, Hot on Wix, IBM Big Insights, Microsoft HD Insights, Amazon Web Services, EMC Square Screenplum, Astrodata from Teradata, HP Vertica, Oracle Big Data, Intel Hadoop, MapR distribution. So you have almost 14 distributions like this, out of which the most sounding are like Cloudera, Hot on Wix, Amazon Web Services. So these are all the most sounding distributions. No matter whatever the distribution you use, the basic concept is always the same HDFS, same MapReduce, but only their user interfaces and their commercials vary from one distribution to another distribution. And these are all the organizations who have been following Hadoop, where by the end of 2015 now, we are expecting almost 90% of the industry will be migrated for Hadoop. So this is a simple introduction of Hadoop, and if you have any questions, now you can unmute yourself and you can fire me with your questions. Please go ahead. Thank you.